there is a formula that you can use for calculating compound interest, right? Probably an exam won't ask you to derive it, but let's look at it anyway. You don't want to just write down the formula and trust it. Let's take a look at it and see if it really would work out. All right. Example. I'm going to use an example to see if we can build the formula. Let's say you invest $1,000. That's your principal at 10% per annum compound interest for 3 years. So you start out with your $1,000. You start out with $1,000. How much money would you have in the account after your first payment? Let's say this is payment of interest. This is payment 1. The amount of money you would have is your $1,000 which you started out with, plus the bank you invest in. Calculate your interest, 10% of your $1,000, and that's $100. Good. Now you would end up with 1,000 plus 100, which is $1,100. Nice. Payment 2. The amount of money you have is 1,100 plus 10% of your $1,100. This would be $110, and when they add that to your $1,100, you would have 0 plus 0 0, 1 and 0 1, 1 and 1 2, 1, $1,210. Nice. Payment 3. The amount you have after that payment, you have your $1,210, and then the interest added would be 10% of your $1,210, and this would amount to $121. So the total amount, the interest you get is 121, so the total amount would be 1 plus 0, that's 1, 2 1 1 is 3, 1 and 2 is 3, 1. So you get $1,331, I mean. All right, let's see what happened here. Upon payment 1, this is what you have. Now 10 over 100 is the same as, in decimal, 0.1. So you could say that this money, let me draw a line here to kind of separate what I'm doing. This money is 1,000 plus 0.1 of 1,000, right? But then 1,000 plus 0.1 of 1,000 is like you're saying 1,000 plus 0.1 1,000 will give you 1 plus 0.1 is what? 1.1 of 1,000. All right. So 1.1 of 1,000. That amounts to your 1,100. Nice. Payment 2. You had your 1.1 of 1,000, which was your 1,100. Then that was added to 10%, which is the same as 0.1, of this of your 1.1 times 1000. Alright, let's see if we can do some factorization. What common factors do we have here? We have 1000 as a common factor. Alright, so we can put it outside the bracket. 1000. Oh, also 1.1 is a common factor. So 1000 times 1.1. I don't see any other common factors. And this is a plus sign here. We have only multiplication sign to the right of the plus and multiplication sign to the left of the plus. So we can just say 1000 into 1000 goes 1, 1000 into 1.1 goes 1. So we have 1 plus. In other words, if we multiply out the 1000 by this and the 1.1 by this, we get 1.1 times 1000, just like up here. Alright, 1 plus. What do we write here before we close the bracket? We already have the 1.1 and the 1000, so this is 0.1. Okay, this is factorized. But the question now is, what is 1 plus 0.1? It is really 1.1. So it is 1000 times this 1.1 times this new 1.1. So it is $1,000 times 1.1 squared. That's the money you have after year 2. Or we're encroaching into year 3 space, you know. But let's put that up here. Payment after year 2 is really 1000 times 1.1 squared. Let's also check it before we move on. Does this really amount to $1,210? 1000 times 1.1 squared. Let's check on our calculator. Put it in advanced mode. 1000 times 1.1 raised to the power of 2 equal 1210, and we have our 1210. Alright, so that part works out. Now, what we have here is upon payment 3, what happened? Upon the third payment, what we have is our money here. We have our $1,000 times 1.1 squared, but we will add that to our 10%, which is 0.1 of this money of 1000 times 1.1 squared. Alright, now let's factorize again. Common factors, we have 1000 as a common factor. Remember, we have the plus sign in the middle. Alright, 1000 as a common factor, 1.1 squared as a common factor. Good. I want you to pause and factorize this, and let me see what you have. Pause. Okay, we're back. Have you factorized it? Let's see. If we put 1000 times 1.1 squared, that's our common factor. 1000 times 1.1 squared into 1000 times 1.1 squared is 1 plus, and this 1000 into 1000 is 1.1 squared into 1.1 squared is 1. All we're left with is 0.1. but 1.1 plus 0.1 is 1.1. So what we have is 1,000 times 1.1 squared times 1.1. So it amounts to 1,000 times 1.1 cube. Alright, 1,000 times 1.1 cube. Let's just check this. Is it the same as 1,310? 1,000 times 1.1 cube. Okay, 1,000 times 1.1 raised to the power raised to the power of 3 equal 1331. All right, 1331. Right, it works. Now let's see if we can come up finally with that formula. Let's make some space here. 1,000 was the principal, so it seems as if the amount that you have after a certain number of payments is the principal. Now the 1.1, this could be written, the 1,000 times 1/10 of 1,000 can be written as 1,000. When you factorize this, this is 1. When you factorize this part, well, factorize this part, I mean, when you take this and factorize it, you have 1,000 outside the bracket, so you have 1 plus 10 over 100. So this now is 1,000 times 1.1. So this 1.1 thing here is really 1 plus 10 over 100. And 10 is really the rate. Let's write it in this form first. The amount of money you have is $1,000 times 1 plus 10 over 100, because the 1.1 is really the 1 plus 10 over 100 to the power of 2 after the second payment. After the third payment is to the power of 3, so after n payments is to the power of n. But in a more general form, it might not have been 1,000, it might have been 100, or it could be 5,000 or whatever. So let's just call it this the principal, instead of saying 1,000 as a specific number. Is a principal amount of money. So this formula, we've seen so far that it has worked for us. A is equal to P bracket 1 plus 10 over 100 to the power of n. But then again, this 10, it might not have been 10%, it could have been 5%, 15%, whatever. So let's get rid of this 10 and put, since it's rate, put R. So it's A is equal to the principal bracket 1 plus the rate over 100 close bracket to the power of n. So we have finally our formula, our compound interest formula here. This is our formula. So the amount is principal, open bracket, 1 plus the rate over 100 close bracket to the power of n. So that is our compound interest formula.